We're going to look at the other 4 trig functions. There are 6 total. So far we've seen sine and cosine. We're also going to look at, some of these are the reciprocals. We're also going to look at secant, cosecant, cotangent, and tangent. In addition to that, we'll be looking at one more way of memorizing how these functions are put together. Let's go ahead and get started by just talking through what each of these abbreviations stand for. So I can go ahead and write these in here. So SEC is secant. CSC is cosecant. COT is cotangent. And TAN is tangent. It's important to start off with cosine and sine before we dive into these other ones. So just remembering from what we saw earlier, the cosine of some angle theta is equal to x on the unit circle, or x over r if we're off of the unit circle. The sine of theta is the y-coordinate on the unit circle, or if we're off of the unit circle, we get that trig ratio of y over r. And we're looking at this. See if I can kind of draw a unit circle there, and I'm just there in quadrant 1. So x coordinate, y coordinate, and then this would be either r, or if we're on the unit circle, that would be 1, so quadrant 1. Let's go ahead and get into each of these. Cosecant, so I've got that written up above. Cosecant is the reciprocal of sine, so it's equal to 1 over sine of theta. So on the unit circle, I want to go ahead and just take the reciprocal of y, so that would be 1 over y. Circle of radius r, it's going to be r over y. Next is secant. Secant is the reciprocal of cosine. So that means on the unit circle, it would be 1 over x. Circle with radius r, it would be r over x. Tangent. Tangent is actually a quotient instead of a reciprocal. It's the quotient sine over cosine. On the unit circle, that would be sine is y, so y over x. If I'm off of the unit circle, I'm going to do this off to the side in green. It would be y over r divided by x over r, but these r's end up canceling, so we get the very same ratio of y over x, so it's the same. Finally, cotangent. So cotangent, we can think of this guy as a reciprocal. So we can think of it as 1 over tan theta, but we can also think of it as the quotient cosine over sine. Okay, so if I just reciprocate tangent, that's probably the easier way to think of it. I get x divided by y, and just like tangent, we get the same thing whether we're on the unit circle or a circle of radius r. So this gives us all 6. So we've got the sine and cosine and their either reciprocals or their quotients. You'll notice that there is this prefix to a bunch of them. We have secant and cosecant, tangent and cotangent, sine and cosine. It's because they act on complementary angles and result in the same value. So for example, if I were to do the sine of 30 degrees, okay, so this is just really good review. So the sine of 30 degrees, I'm running out of room here. I want, if 30 degrees is here, I want the opposite side. That's going to be 1/2. So that's 1/2. If I look at the cosine of 60 degrees, okay, so now I've got the cosine of the complementary angle. These two add up to be 90. So the cosine of 60 degrees is going to be the x, which is still opposite 30, and I get 1/2. So that's going to be true for all of these. So the co means you get the same trig ratio or the same result for complementary angles. Complementary angles. Complementary means that they add to 90 degrees. Okay, so just kind of an interesting sidebar, not anything you need to memorize, but it's nice to know where that language comes from. A really good way of thinking these through is to step away from the unit circle for just a minute and think about how the sides are relative to one another. And we're going to do that with this memorizing device, Sohcahtoa. So, S is for sine, C is for cosine, and then toa, the T is for the tangent. I'm going to go ahead and put an angle here. This is a right triangle, and I'm going to label these relative to my angle. So relative to my angle, this would be the adjacent side, or right next to. Over here, this leg would be the opposite side. And then, of course, across from the 90-degree angle is the hypotenuse, which I can't spell. Hypotenuse, there we go. Well, we think of these as we work around this using Sohcahtoa, we think of this as A for adjacent, O for opposite, and H for hypotenuse. So when I break this down and I look at this is the sine of theta is opposite over hypotenuse. Okay, the sine is opposite over hypotenuse, and that would work with our y and our x's. Next is ca, so that would be CAH. This tells me that the cosine of theta is equal to A, which is adjacent over hypotenuse. So adjacent would be this side here, and if I was on the unit circle, that would be my x over the hypotenuse. And then finally, tangent is from toa. So toa is opposite over adjacent. So tan of that angle theta is opposite over adjacent. This lets me find those values even when I'm not on the unit circle. Let's go ahead and work through some examples. I really want to focus on, to start with, that secant, cosecant, cotangent, and tangent. And I'm just going to remind you here that secant is 1 over cosine. Cosecant is 1 over sine. Yes, you should memorize these. Cotangent is 1 over tangent. And tangent is y over x, or sine over cosine. Okay, so first of all, we've got an angle of pi. So I land on this point. Pi is a quadrantial angle, and I land at the point -1, 0. So secant is going to be 1 over cosine. That's going to be 1 over x, 1 over -1, or -1. Next, we have cosecant. Cosecant is going to be 1 over y. Y is 0, so this would be 1 over 0, which is undefined. So once we get into these reciprocals, we fall into some undefined values. Cotangent. Cotangent is 1 over tangent. That's going to be x over y. X over y is going to be -1 over 0, undefined again. It says undefined, undef for undefined. And then finally, tangent. Tangent is going to be y over x. Y is 0, x is -1. This is defined, and this one is 0. Next, 5 pi 6. Okay, so again, I'm working in terms of half a rotation or a full rotation. I just want to get close to one of those. Pi is 6 pi 6, so that's going to work for me. So 5 pi 6 gets me almost all the way there. I'm just pi 6 short. So this reference angle here is pi 6. Let me go ahead and pull that off. Pi 6 is my smaller angle, so this is going to be opposite of 1/2. I have positive y's and negative x's, so this is my pi 6. This is going to be pi thirds, so we're going to have a bigger opposite side, radical 3 over 2, which is going to be negative. So this gives me the point negative radical 3 over 2, 1/2. X y. Okay, so here we go with secant. Secant is 1 over cosine. Cosine is our x, so it's going to be the reciprocal of x. X is, let me do this in a different color here. X is negative radical 3 over 2. So we're going to call that negative 2 over radical 3. If you really wanted to rationalize this, you could. I don't care. I think what you've got right there is fine. If you multiply this by radical 3 over radical 3, you get negative 2 radical 3 over 3. This is fine. Next, cosecant. That is 1 over sine, or 1 over y. So the reciprocal of y is 1/2, so that's going to be 2 over 1, or 2. Cotangent, let's actually do tangent next, just because that's the way my brain works. Tangent is y over x. Y is 1 over 2. X is negative radical 3 over 2. I'm dividing those fractions, which is the same as multiplying by a reciprocal. And I get negative 1 over radical 3. This is a fine answer. If you want to rationalize by multiplying by radical 3's, you get negative 1, which we don't actually need. So we'll just call that negative radical 3 over 3. But I'm going to go ahead and write the answer that I've circled there, negative 1 over radical 3. This makes cotangent easier because I know it's the reciprocal of what I got for tan, and that's going to be negative radical 3. Okay, next, negative 3 pi fourths. Okay, so again, I go to my unit circle and I work in terms of a half rotation. This time we're traveling negative. So half a rotation would be negative pi, or negative 4 pi fourths. That's really all I need. I'm just going to go a little bit shy of that. So I'm going to travel instead, let me grab my blue pen, to here. This is a pi fourths, so I know I'm working with radical 2 over 2's. I'm in quadrant 3, where everybody's negative. So this point right here has got to be negative radical 2 over 2, comma, negative radical 2 over 2, both my x and my y. I want to start with secant. Secant is 1 over cosine. So that's going to be negative 2 over radical 2. If you were to rationalize that, it turns out to be radical 2. I'm not going to do all of that work, but you can double check me if you want to. Cosecant, it's going to be the same, right? We have some really nice symmetry here, especially in quadrant 3, where the signs are the same as well. So I've got 1 over sine. So this is same thing, negative 2 over radical 2, or if you rationalize that, negative radical 2. Cotangent. Let's do tangent first. Tangent is y over x. Doesn't really matter which one you do on this one. They're the same. So I could write it all out and do all that work and blah, 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 right? Blah, blah, blah. They're the same. So the ratio is a positive 1. Notice how this is on a positive slope. You can think of tangent as the slope. Y over x, rise over run, same thing. So this is going to be a 1. Cotangent is 1 over tan. Reciprocal of 1 is also 1. Okay, next, 4 pi thirds. Let me switch colors. Okay, so 4 pi thirds. So I know because I've got this third that I'm going to end up using 1/2 and radical 3 over 2's. Let's find out where we're landing on the unit circle. I'm going to go ahead and use pi and 2 pi. Pi is 3 pi thirds. That's going to work for us, right? 4 pi thirds is just traveling 1 more pi thirds. So I'm going to get to right here. So that means that my reference angle, I needed to travel just 1 additional pi thirds. My reference angle, this guy, is pi thirds. Pi thirds. Opposite pi thirds is going to be my longer side, which is radical 3 over 2. I'm in quadrant 3. Everybody's negative. So the other side is going to be the negative 1 over 2. Secant is 1 over cosine, or 1 over x. Let me label this point. Negative 1/2, comma, negative radical 3 over 2. So that's going to be the reciprocal of negative 1/2, which is going to be negative 2. Cosecant is 1 over y. that's going to be -2 over radical 3. Or if you rationalize like we did up above, -2 radical 3 over 3. Cotangent and tangent. I like to do tangent first. This is y over x. Y is negative radical 3 over 2. X is -1 over 2. The 2's cancel, and you can do the math to convince yourself, but I'm convinced this is going to be a positive radical 3. Take a look. Tan is your slope, and it's a positive slope, so I'm feeling good about that. Cotangent is the reciprocal of tangent, so it's going to be 1 over tan, so 1 over radical 3. If I were to rationalize that, just to give you a little more practice, radical 3 over radical 3. I don't think I've rationalized one of these yet. Radical 3 over radical 9. Radical 3 over 3. Or radical 3 over 3. That works just as well. Okay, number 5. In this one, it's set up differently, right? I don't have a common angle, and I'm given the ratio instead. So I'm going to go ahead and work backwards through these. And I'm going to use the fact that sine of theta, I don't need to know the angle. I just need to know that that ratio is y over r. I am between pi and 3 pi halves. I'm between pi and 3 pi halves. So I'm in quadrant 3 pi halves. So if I were to go ahead and just draw myself a generic triangle here, y over r is always positive. So I'm going to move the negative up with the 3. So I've got -3 for the y. I don't know what x is. I'll change that into an x. And 5 here. I actually don't need theta. This is theta, but I don't need theta. I just need to know that x, and then I can find all of my ratios. We already have the sine, so I can fill that one in to start. But to find the cosine, I need to go ahead and find what that x value is. Pythagorean theorem. So x squared plus -3 squared is equal to 5 squared. X squared plus 9 is equal to 25. X squared is 16. X is plus or minus 4, but I'm in quadrant 3, so I'm going to choose the -4. So x is -4. So here we go. So I know that cosine is x over r. That's going to be -4 over 5. Cosecant is the reciprocal of sine. So that's going to be r over y, but I already have it, -5, -5 over 3. The negative can go anywhere. And then finally, tangent. Tangent is y over x. Y is -3, x is -4. So we get -3 over -4, or +3/4. And again, take a look at that tangent. It's on a positive slope. Okay, so there's number 5. And then number 6. Number 6, tangent is 24/7. So I want to do the same kind of thing, and I want to build this triangle. Now I'm between 0 and pi halves. So between 0 and pi halves puts theta somewhere in quadrant 1, where everything is positive, x's and y's. I've got 24 and 7. So tangent, let me draw this down here. Tangent of theta is y over x, which is 24 over 7. So I need a really tall triangle. It's going to look like this. So 24 is my y, 7 is my x. Let's go and use the Pythagorean theorem. 7 squared plus 24 squared is equal to r squared. Let me grab my calculator. I know what 7 squared is. That's going to be 49. So 49 plus 24 squared. Whoops, not 26. 24 squared. Shoot. Okay, so 49 plus 24 squared is equal to 625, and I'm pretty sure that's the square root of, I'm pretty sure its square root is 25. So let me just type that in just to be sure, and yes it is, so 25. So r is equal to 25. Okay, so I have my x. Let me write these here. X is 7. Y is 24. R is 25. So 25 goes here, right angle. Okay, secant. Secant is R over X. So my R is 25. I put a box around these, it's easier. 25 over 7. Cosecant is R over Y. R is 25, Y is 24. Tangent is Y over X. Y is 24, X is 7. And then finally, cotangent is the reciprocal of tangent. So I can just reciprocate my last answer, and I get 7 over 24. Okay, last but not least, these are actually the really nice ones as long as you've got your calculator set up correctly. We want to go ahead and do some calculations with a calculator and with Desmos. So I'm going to bring my calculator up here. Let me move it out of the way so we can see everybody. I'm going to clear this. As I'm working these though, and I'm looking through these problems here, notice how none of these have a degree symbol. That means that all of these are radians. All are radian measures. One of the things that will mess you up in this class when you're using your calculator is not putting it in the correct mode. So I'm going to go into mode. Notice here, if I go down to the third line, I've got the choice between, actually on mine it's the fourth, between radian and degree. Make sure you have radian highlighted and then hit enter. Now it's going to give you sines and cosines in terms of radians. So I want to go ahead and start by doing a sine. So I'm going to do sine of 0.2. You don't need to close it with a parenthesis. That's fine. And you get this. We'll go ahead and just keep 3 decimal places. So I get 0.199. And then I can do a cosine of 3.2. But you might notice if you're looking ahead that there are only sine, cosine, and tangent on here. And I get negative 0.998. Next is cosecant. Cosecant is 1 over sine. So I actually need to instead type this in as 1 divided by the sine of -1. So I'm going to go 1 divided by the sine. It's not the same as sine inverse. Oh, whoops. So I'm saying that 1 divided by sine of -1. Sine inverse will give you an angle back. That's not what I want. I want the reciprocal. And I get -1.188. So -1.188. And then cotangent, I know that that's 1 over tangent. Same thing, there's not a cotangent on my calculator. So I'm going to go 1 divided by tangent. And then I want to type in pi/6. Pi is right over here, right above the division key. So I'm going to go second and then hit that caret key to grab pi. And then I want to divide this one by 6. And you don't have to close the parenthesis. I did, but you don't have to. And I get 1.732. 1.732. Desmos will also do a nice job of these for you. So if I go into Desmos, let me go ahead and grab a new view here. And we'll just type some of these into Desmos. I can probably grab them right from there. Great. You can have Desmos on your phone. It's always free on the computer. The nice thing about Desmos is I can just type these in. I'm just going to use the calculator side here. I can just type these in. So I can just ask it for the sine of 0.2. And I get the same thing. So it's assuming that I am in radians. If I want to do, let's see, I can do the 1 divided by sine. Let's see if it recognizes cosecant. And it does. See how I can tell? It starts it out when I do the C and the S, they're italicized, and it's asking me if they're variables, add a slider. But as soon as I hit the C in, it recognizes it. So this is actually really nice. And I type in -1. And I can do the same thing with that tangent. That one wants a cotangent. So CO, it doesn't recognize it yet. I put the T in and it recognizes it. To do pi, you can do one of two things. You can go ahead and click on the keypad, and then you can look for your pi symbol, which is right here. You can also just type in the letters PI, and it will recognize that as pi. Isn't that nice? And then divide by 6. And it recognizes that you are in radians. So there's a couple things that you can do. You can change your settings here. These are your graph settings. You can also go into your functions, and under Trig here, we've got all of those Trig functions that it recognized. And then I can also go over here to miscellaneous, and I've got, oh, actually none of them are there. So they're all just right there in the Trig functions. So Desmos or the calculator, either way, they'll both do a really nice job of computing these only as decimals, only as rounded numbers, but they'll do a really nice job of computing these for you, as long as you're allowed to use a calculator for some of these problems. If you wanted to do some trig functions in degrees, it's easy to switch both the calculator or Desmos into degrees. We were just working in Desmos, so let's go ahead and switch Desmos first. I'm going to click on the wrench. And at the very bottom, in really nice, big, bold print, you've got either radians or degrees. Let's go ahead and switch over to degrees. So if I now do these, notice how these numbers here have changed. And I can ask it for something like, if I do the cosine of 180 degrees, that should be a -1. So 180. And it is, in fact, a -1. If I want to change it in my calculator, I'm going to go to mode. So I go to mode, and I'm going to arrow down until I see radian and degree, and I go ahead and I choose degree, and I can quit and start doing some calculations in degrees. So I can do, let's see, we're doing the cosine of 180. So if I do the cosine of 180, I end up getting the same thing, which is -1. Now, if I were instead to do the cosine of pi, I'm in degrees. It's going to assume that I mean pi as in 3.14 and so on. So in degrees, if I say the cosine of pi, pi, it gives me this 0.99 number. If I do the same thing over here and I ask it for the cosine of pi, again, it thinks I mean degrees. So it's giving me the cosine of 3.1 degrees. So if I go ahead and click on pi here and then enter, it gives me that same value. So again, in Desmos, you can go ahead and switch between degrees and radians using the wrench, radians and degrees here at the bottom. And in the calculator, you want to go into your mode. So you click on mode and then arrow down to radians and degrees.